2, I can see a triangle out of this, and I want to make that triangle with the nearest x-axis. And we can see that this length is 5, negative because it's going in the left direction, and this guy is 2. Now, if I want cosine, I need adjacent, we got that, 5. Okay, and I need my hypotenuse, which I don't have. But we've created a right angle triangle. So now we can use Pythagorean theorem. This guy here, which I'll call r squared is equal to 5 squared plus 2 squared. Now, again, I dropped the negatives when I'm working with that little triangle. The negative told me what quadrant to put it in. Now I'm just dealing with that triangle that's 5 units with a base 2 units high. So we have r squared is equal to 34. No, 29. And their r is equal to square root 29. And keep that square root 29 in exact form. I look at it, I can't reduce it any further. Can't write it to a smaller mixed radical. So r is square root 29. So now I have my opposite, my adjacent, and my hypotenuse. And now we're just going to go back to our basic definitions. We have cosine is equal to 5 over square root 29. But I'm in the second quadrant. So what is the cosine of that guy right now? Positive or negative? Karen? Quadrant 2, cosine, positive or negative? So we can't forget that we have to use our cast rule. We found the ratio from the triangle, now we deal with the cast rule. Sine is 2 over square root 29. Sine is positive in quadrant 2. Cotangent is adjacent over opposite. So 5 over 2. Now I'm just reading my triangle. Cotangent and tangent in the second quadrant are positive or negative? Derek? Oh, we have to make sure that we include that negative. Now I'm perfectly fine on a response using this negative 5 over square root 29. But on a multiple choice, we have to know how to go to the value that we're probably going to see on a multiple choice. Multiply both top and bottom by square root 29, because that's what I've written in green is 1. So we got negative 5 square root 29 over 29. And down here we would do the same thing to get 2 square root 29 over 29. Don't write square root 29 as 5.2 times or whatever, but leave it in exact values, and if you can, reduce it to a smaller value. So if you get square root 20, you can reduce that down to 2 square root 5, and you can work this out. So that's one way that we could work off of it. I give you a point off the unit circle, which I did in this case. I can give you a point on the unit circle, or I can give you as I did in one of the questions yesterday, I can only give you the y coordinate, which you can recognize, hey, I gave you opposite over adjacent, or opposite over hypotenuse, and you can work from there. I can give you a trig ratio and something that allows you to find the quadrant. This is that kind of what I was talking about. We have sine is equal to negative 8 over 15. And I'm telling you, I'm looking between pi and 3 pi over 2. So I'm looking at in quadrant 3. A second way that I could say this is tangent is negative. So where is sine negative? And 3. I said tangent is positive. Where is sine negative and where tangent positive? Well, that was quadrant 3. So I'm going to again deal with my triangle. From sine, ignore the negative 8. I'm just going to use the 8. The 8 is the opposite. There's my angle. That guy is going to be opposite. 15 is your hypotenuse. And now you have enough information to find the adjacent in this case. It's going to be 15 squared is equal to 8 squared plus x squared. 225 minus 64 is equal to x squared. Oh my goodness. 121? No. 225 minus 64. It's not a special triangle. It's not a Pythagorean triplet, so I can play out.
160.
So, thank you. X squared is equal to 161. X is equal to the square root of 161. I'm going to try to reduce it. I know it doesn't. 4 doesn't go in because it's even. It's not divisible by 9. I know that because 1 plus 6 plus 1 doesn't add up to be divisible by 9. Okay, so there is nothing that goes into 161. 169 is the next perfect square. So what we have here, we now have enough information to do exactly what we did before. We want secant and tangent. So secant theta is a reciprocal of cosine. In quadrant 3, cosine is negative. And it's going to be hypotenuse over adjacent. And I'm just looking at the triangle there. The negative came from the quadrant. The tangent is positive because it's quadrant 3, and that's going to be opposite over adjacent. And again, you can rationalize, and probably would be expected to rationalize the denominator on a multiple choice question. This idea of using triangles, very, very useful for us. Questions on that one? Now, we are also going to ask to solve trigonometric equations. Now, we've already kind of done that. I did a couple yesterday. Solve them for quadrant 3, solve them for quadrant 2, something like that. But most likely, I'm going to ask you to solve I think I made a mistake and forgot to put 360. As I repeated myself, what I put in green is actually should be. Those are the two that I'm going to give you most often. Determine the value of x between 0 and 360 or 0 and 2 pi. Okay. Or 0 and 720. I can't agree. I can do that also, or will do that also. Here's the thought process that I go through. I want to solve sine theta is equal to negative 1/2 for between 0 and 2 pi. I'm going to speak degree or radians most of the time. My first thought, where is sine negative? Well, which two quadrants is sine negative? Down here. And I'm going to draw my two quadrants. I have two solutions for this. One in quadrant 3 and one in quadrant 4. The reference angle, that's my next step. What is the reference angle? Where is sine equal to 1/2? Now, 1/2 comes off of our special triangle. So the reference angle is equal to pi over 6. Again, using the special triangle in my head that I use way too much. So here we have a reference angle of pi over 6 and another reference angle of pi over 6. We have two solutions. We have theta in quadrant 3 is going to be pi plus pi over 6. So pi plus pi over 6 is 7 pi over 6. And in quadrant 4, the angle is going to be all the way around to 2 pi and then back up pi over 6. So 2 pi minus pi over 6, 11 pi over 6. So what I do, again, to quickly do this, it's 8 pi over 4, or sorry, 12 pi over 6 minus pi over 6. If you're doing it on your calculator, it's 2 minus a 6. Leave the pi out of the answer. You're never going to get an exact value of that. Again, this is exactly what you did last year, except you were doing it in degrees. You made the subtraction and addition of those. Tangent is equal to 8.5. What quadrants are tangent positives in? There's one in quadrant 1 and one in quadrant 3. So there's a solution in quadrant 1 and a solution in quadrant 3 that we need to work on. 8.5 does not come off my special triangle. The numbers are 1/2, square root 3 over 2, 1, square root 2 over 2, 1 over square root 2, and then the reciprocals. That's not one of them. So, my reference angle is inverse tangent of 8.5. Now, if this was a negative 8.5, I would still use this exact same thing because I want a reference angle between 0 and pi over 2. So, I'm asking you in radians. Make sure your calculator is in radians. Do not give me the answer in degrees. Okay? So last year you were always in degrees. Now you need to go back and forth between degrees and radians. And you will need to go back and forth because Mrs. Lowry is going to put you in degrees whenever you do any type of two-dimensional work. So we're looking at somewhere around 1.2-ish, I'm guessing. Maybe 1.4-ish. What do we get? So the reference angle is equal to 1.45. I go ahead and I put this on. There's my reference angle. There's one reference angle, and my other reference angle. Then the other angle down is going to go here. I have a solution in quadrant 1, which is just equal to the reference angle. I have a solution in quadrant 3. It's going to be pi plus 1.45 because I'm going from here to here and then adding a little bit more. And that's going to be approximately 4.59. This thought process is not something that I made up. Now, the only difference, some teachers teach equations. I don't. Anytime I ask you to solve an equation, I want to see where the quadrants are visually, and that allows you to figure out, oh, what do I need to do? I need to go to pi and add a little bit, or I need to go pi and back up a little bit. Instead of having to remember it's quadrant 2, so I gotta go pi minus our reference angle. Quadrant 3, pi plus. If you have the visual, you don't have to memorize those things. Okay. Are there any questions on this? Just sparking the memories from last year. Now, what happens if I give you them in slightly different forms? I give you an actual equation that is equal to 0. Well, treat it the same way. 2 secant theta minus 1 is equal to 0. I can solve this so secant theta is equal to 1/2. Why I keep doing this, but oh well. Not as bad learning. Now, here's something we can do. It's secant. Might have secant at 1/2, but let's just flip both sides. Cosine theta is equal to 2. Now, there's no solution to this one. How do I know that? Because cosine theta is never going to be larger than 1, and never smaller than -1. So cosine theta has a range of 1 to -1. And it can be equal to 1 or -1. This here, I can't, if I punch in inverse cosine of 2, actually please punch in inverse cosine of 2. You get out error, right? So, in this case, we have no solution. Sine is also this way. Sine has a range of -1 to 1. So I can't ask you to solve sine theta of 3 or 1.5. Well, I guess I can ask you to solve it. You just tell me it has no solution. Tangent, cotangent, secant, cosecant can be larger than 1 and less than -1. Okay? Now this one looks a little bit clumsy, not bad. It's a linear function. This is called a linear trigonometric function because what's the degree of the tangent? It's just 1. Okay? So, how do we solve any linear function? Get the variable on one side. I'm going to subtract tangent from both sides, and I'm going to subtract 3 from both sides. Okay, so I'm just basically treating this tangent x, the tangent theta as a variable, moving it to the other side. Now this is exactly what we had on the last question. Tangent is negative in quadrants 2 and quadrants 4. My reference angle is going to be found by going tangent, inverse tangent of 4.5. It's on the range of about 1 and change, 1.1 or something. Karen, did you get a reference angle for that one? Okay, so we have a reference angle of 1.35, that is here, and it is here. Please make sure that the reference angle goes between the terminal arm and the nearest x-axis. We have quadrant 2 is pi minus 1.35, and quadrant 4 is 2 pi minus 1.35. Again, all the way up, back, all the way to pi, back up, all the way to 2 pi, and back up. That's how I remember my work. Someone just do those 1.8 and 4.8, I'm guessing, ish. would you get for those two? Now, we have, those two were linear, so we treated them like linear equations. They had degree 1. These guys here are not linear, they are degree 2. Now, what does sine squared x mean? Well, it's a shorthand notation for sine x squared. So when I write sine squared x, this is what I'm meaning. I'm taking the sine of our known value and then I'm squaring it overall. Well, what do you have to do when you have a second degree function or second degree equation that you want to solve? With these two, you can kind of treat them the same way as a linear, but you have to be careful. Or you have to factor, right? And we're going to get into the factoring. I'm going to solve this one way, and I'm going to solve that guy another way. Sine squared x is equal to 1, therefore sine squared x is equal to 1. I take the square root of both sides, and I'm about to make a mistake. And I'm about to make the mistake that most people make. Yeah, the square root of 1 is 1. What else is the square root of 1? Sorry? Negative 1. So, we took a positive. We have to make sure when we take the square root like this, and we can do that because it's a 2-term with no middle term, we have sine x is equal to plus or minus 1. So we have a solution for sine x plus 1, sine x minus 1. Sine x is equal to plus 1 up there. That's off my cardinal points. And sine x is equal to negative 1 down here. So what we have here is we kind of have those ones memorized. We have one solution is pi over 2, and the other solution is 3 pi over 2. Now, I just put 1, 2 because it's between the solution between quadrant 1 and quadrant 2. Now, I don't know why I use theta instead of x, but theta, x, alpha, beta, doesn't really matter. You can interchange. So there is the most important thing there, that you're going to have a positive and a negative. Now we are able to do the same thing here, but I also want you to recognize that this is a difference of squares factoring. You have something squared minus something. Now in this case, what is the square root of 3? The square root of 3. Right? We can factor this one. Cotangent theta minus square root 3. Cotangent theta plus square root 3 is equal to 0. Okay. Now, I'm not saying you have to do it this way. I'm saying, hey, that's a difference of squares I can do. And yeah, we got a 3. 3 isn't a perfect square, but we can write it as square root 3. We're going to end up with that. My solutions are, from this guy, theta is equal to positive square root 3, or sorry, cotangent theta. Try that again. And cotangent theta is equal to negative square root 3. Okay. So again, we have the positive values there and there, the negative values there and there. Okay. Now where square root 3 is one of our special numbers off our triangle. Cotangent is adjacent over opposite. So by reference angle, is pi over 6. I just wrote this down because I wanted to make sure. Yeah, adjacent over opposite, that guy is my pi over 6. So I have 4 solutions, and I ran out of room. I'm going to just do another page. We have solution quadrant 1 is pi over 6. Solution in quadrant 2 is pi minus pi over 6. Solution in quadrant 3 is pi plus pi over 6. And your solution in quadrant 4 is 2 pi minus pi over 6. 11 pi over 6. Okay. I'm going to go back to this tomorrow. So the only difference in the homework and the whiteboard work is I want you to don't worry about the general solutions. I'll go over that tomorrow with you. Spend a little bit more time talking than I wanted here. I want you guys to get some practice at this. So I'll go over the general solutions tomorrow. Please remind me to do that, and we'll go from there. Make sure you're speaking the question if they're speaking the language they ask the question. Let's go. That's what they're get through the question call and last 15 minutes of
No. Yeah, I'll bring it to you guys. We're good?